Hello, I'm Arsenio Nicolas Jr. and with my groupmate Andrei Insigne. In the first part of our SVM activity, loading the dataset, we focus on preparing the data. We use the dataset given to us that has information about people's health and we're trying to find out if a person is at high risk or low risk of a certain condition. The dataset originally had a lot of features or columns, but to keep things simple and easier to visualize, we decided to choose only two features: cholesterol and systolic blood pressure. We chose these two features because they are both known indicators of health problems, especially related to the heart. Using only two features also helps us make a 2D graph later on. We also separated the features x from the target variable y, which tells us if the person is high risk or not. After that, we scale the features using something called standard scaler. This step is important because SVM works better when the features have similar ranges of important values. Without scaling, the model might focus too much on one feature just because its numbers are bigger. Now for part 3, training and testing SVM models. We tested three types of SVM kernels: linear, RBF or radial, basic function, and polynomial. Here's what the results tells us. For linear SVM, from the confusion matrix, we can see that 171 low-risk patients were correctly classified, while 4 were incorrectly labeled as high risk. For high-risk patients, 13 were correctly classified, but 12 were misclassified as low risk. Its classification report are precision for class 0, low risk is 0.93, while for class 1, which is high risk, is 0.76. This means the model is more confident and accurate in predicting low-risk individuals, while the recall for high risk is only 0.52, meaning it misses almost half the actual risk cases. Overall, accuracy is 92%, but the model struggles a bit with high-risk predictions. Now for RVF SVM, the RBF kernel slightly improved the correct classification for low-risk patients and reduced false positives, but it still struggles with high-risk predictions, correctly identifying only 11 out of 25. Now, for the precision for high risk is 0.79, but the recall for high risk is 0.44. While precision is decent, the recall is even lower than the linear model, which means it's still missing over half the actual high-risk cases. The accuracy is 91.5%, just slightly below the linear model. And lastly, polynomial SVM. Surprisingly, the polynomial kernel gave exactly the same results as RBF kernel in this test. Again, precision is 0.79 for high risk and recall is 0.44 with overall accuracy of 91.5%.
Moving on to the part 4 of our SVM machine. So this model with an RBF kernel classifies individuals as either high risk or low risk of a heart attack based on cholesterol and systolic BP values. So since it's using an RBF or radial basis function kernel, the boundary is nonlinear and can curve to better separate the classes. So for the data points, each dot represents an individual from the dataset. The purple dots, which is 0, it represents individuals classified as low risk. As for the yellow dots, it represents individuals classified as high risk. So as you can see from the graph, you can see that the yellow or the high risk dots are scattered across the plot and are not clearly separated from the purple or low risk ones. So this tells us that cholesterol and systolic BP alone are not enough to perfectly separate the high risk and low risk individuals, and there may be overlap in values. However, the RBF kernel still tries to form a nonlinear boundary to classify the data as best as it can. So to sum it all up, we successfully used SVM to classify whether a person is high or low risk using only two health features: cholesterol and systolic blood pressure. We scale the data, train the model using the RBF kernel, and visualize the results with a clean plot that shows both the predictions and actual classes. Even though we only use two features, this simple setup still shows the power of machine learning. Doctors or medical professionals could use tools like this to help them quickly assess risk based on just a few test results. And of course, in real world use, we'd probably use more features and fine tune the model more. But for now, this was a good way for us to learn how SVM works and how it can be applied in health related problems.